Good day, my dear SS2 students. How are you doing? Your siblings and your parents. I hope everyone is doing very great. My name is Mr. Seun Akimolayan, your physics teacher from Sleek Angels International School. It is my pleasure to bring this online class to you, and I'm sure it's going to be a worldwide session. Our topic is reflection on curved mirror. Reflection on curved mirror. The previous video class was on reflection on plane surface, and I have received quite a number of responses based on the homework. But if you have not forwarded your homework, please do so. Okay. Reflection on curved mirror. Our objectives for this lesson. By the end of this lesson, you should be able to identify types of curved mirror, the nature of images produced. You should be able to understand the uses of curved mirrors, and then also know how to apply mirror formulae. Okay. Types of curved mirror. What is a curved mirror? A curved mirror is a mirror with a curved reflecting surface. The surface may be either convex, that is, bulging outward, or concave, recessed inward. In the previous class we talked about plane surface and plane mirror. But in this lesson, we shall be considering curved mirror, which could be curved inside or outside. Now, we said a mirror is formed when a glass is painted at one side. When a glass is painted at one side, a mirror is formed. Now, the mirror could be plane mirror or curved mirror. We have considered the plane mirror. So for this lesson, we're dealing with curved mirror. All right, basically, there are two types of curved mirror. We have the concave or converging mirror. Number one, the concave or converging mirror. And then number two, we have the convex or diverging mirror. So quickly, let's take a look at these two types of curved mirror. Concave or converging mirror. Concave or converging mirror. This is formed when a glass is silvered from outside so that light can be reflected from inside. This is formed when a glass is silvered. The word silvered there could also mean painted, when it is painted from outside so that light can be reflected from inside. Now, look at this diagram. The two yellow arrowhead is showing, the two yellow arrowhead are showing where light can come from. So light comes from this side, the one at the top. Also, light can come from the one at the base. Now, the inside of the mirror is the reflecting surface. And then at the back of the mirror is where it is painted. So this is a concave or converging mirror, and it has various components, as we shall look at those components shortly. But before we do that, let's look at some of the components here. We have the principal axis at the back of the mirror. The principal axis is that line, the straight line where you have the center of curvature, you have the focus, and then you have the P. The P there is the pole. The pole is the center of the reflecting mirror. It is center of the reflecting mirror. Then we have the focus. We have the focus. Now the distance between the pole and the focus is called the focal length. The distance between the pole and the focus is called the focal length. Now we also have center of curvature. The center of curvature is twice the focus. The center of curvature is twice the focus. And the distance between the pole and the center of curvature is called the radius of curvature. The distance between the pole P and the center of curvature is called the radius of curvature. Now please take a look at the note. The note there at the down right, we have R equals 2F, meaning radius of curvature equals twice the focus, or we can say the focus equals the radius divided by 2. R divided by 2. Radius of curvature divided by 2 will give the focus. So where R is the radius of curvature and then F is the principal focus. Okay. Now, for a convex mirror or diverging mirror, it is formed when the coating, that is the painting, is done so that the reflection is from outside. Convex mirror is formed when the coating or the painting is done so that the reflection is from outside. Now take a look at that diagram. You discover that the reflection is at the left hand side. Now the painting, which is at the right hand side, is inside. So the inside is painted while the outside is the reflecting surface. Unlike the concave mirror where the outside is painted and the inside is the reflecting surface. So please, this is a major difference between the convex mirror and the concave mirror. Let's go on. Now let's look at definitions of some essential parts of curved mirror. Essential parts of curved mirror. Number 1, the pole. The first one, the pole P. It is the center of the reflecting surface of the curved mirror. It is the center of the reflecting surface of the curved mirror. And then the center of curvature, the second one, the center of curvature, C. It is the center of the sphere of which the mirror forms a part. By definition, that is it. But the center of curvature is the distance between the pole, is the radius of curvature. So the center of curvature is from the pole to C. And then that distance is the radius of curvature. So that takes us to number 3. The radius of curvature, R. It is the distance from the pole to the center of curvature, CP. The radius of curvature is the distance from the pole to the center of curvature. Okay, the fourth one, the principal axis. The principal axis. It is the parallel line PC from the pole to the center of curvature. When a beam of light is incident on a curved mirror, the rays are reflected or diverge from a point called a focus, like we saw in the 2 diagrams. So the principal axis, it is the parallel line PC from the pole to the center of curvature. When a beam of light is incident, that is, when a beam of light strikes the curved mirror, the rays are reflected or diverge from a point called a focus. Okay. Now, the principal focus. The principal focus of a concave mirror. The principal focus of a concave mirror is different from the principal focus of a convex mirror. Let's look at the definition. The principal focus of a concave mirror, it is the point where rays that are parallel and close to the principal axis converge after reflection. The principal focus of a concave mirror, it is the point where rays that are parallel and close to the principal axis converge after reflection, and that is why a concave mirror is also called a converging mirror. A concave mirror is also called a converging mirror. Now let's look at the principal focus of a convex mirror. It is the point from which rays parallel and close to the principal axis appear to diverge after reflection. So, the convex mirror is also called a diverging mirror. Please take note. The concave mirror is called a converging mirror, while the convex mirror is called a diverging mirror. Hence, the focus of a concave mirror is real, since the converging rays can be seen on the screen, but that of convex mirror is virtual. Hence, the focus of a concave mirror is real, since the converging rays can be seen on the screen, but that of convex mirror is virtual. Now, we differentiated between real and virtual in the previous class. Real rays produce real images. Virtual rays produce virtual images. Now, a real image is formed on the screen or can be cut on the screen, while a virtual image cannot be formed and cannot be cut on the screen. We actually differentiated this in the previous class. All right, let's move on. Now, we're going to look at the formation of images by spherical mirror. Formation of images by spherical or curved mirror. And before we look at those images, let's take a look at the rules guiding how those images are formed. There are rules guiding how those images are formed. The first one, rays parallel to the principal axis pass through the principal focus after reflection. The first rule guiding the construction of images formed by spherical or curved mirror is, the first rule is, rays parallel to the principal axis pass through the principal focus after reflection. Please take note of this so that by the time we begin to look at how those images are being formed, you can now know how those rays are reflecting and all of that. Okay, number 2, rays through the principal focus are reflected parallel to the principal axis. Rays through the principal focus are reflected parallel to the principal axis. And then the last one, number 3, rays passing the center of curvature are reflected back along their path. Rays passing the center of curvature are reflected back along their path. So please take note of these 3 rules guiding the construction of images formed by spherical mirror. All right. Now, what are the characteristics of images formed by concave mirror? So we're going to start with concave mirror. Formation. Let's look at the characteristics of images formed by concave mirror. Characteristics of images formed by concave mirror. Number one, when the object is at infinity. When the object is at infinity. Now let's look at the diagram very carefully. The object is AB at infinity. The object is AB. The ray of light from the head of the object at A, striking the mirror at D, reflects back through F. The ray from A, striking the mirror at D, reflects back through F, which is the focus. Also, the ray from B, from the base of the object, striking the mirror, reflects back through F. The point of intersection or the meeting point of the rays is where the image is formed. The meeting point of the rays is where the image is formed. So, for the object at infinity, the image is formed at F. The image is formed at F. So, the characteristics therefore is that the image is at F. The first one. The second one, the image is real. The image is real because it is formed on the screen. It is formed on the screen. The image is inverted. That is upside down. Is inverted. And the image is smaller than the object. The image is smaller than the object. Okay, let's look at the second position. When the object is beyond C. When the object is beyond C. Now, from the diagram, the object is AB. The object is AB. The ray of light that is parallel to the principal axis is from A. So from A to the mirror, striking the mirror, reflects back through F. The ray that is parallel to the principal axis is from A. Striking the mirror, reflects back through F. Also, the ray passing through the center of curvature. The ray passing through the center of curvature must definitely reflect back. Must reflect back through the same path, C, that is the center of curvature. And then you now have the meeting point at A. Therefore, the image formed is BA. The object is AB, and the image formed is BA. You can deduce the characteristics of such image, therefore. So, the image is, number one, is formed between C and F. As you can see from the diagram, the image is between C and F. Also, the image is real. It is real because it's on the screen. The image is real. The image is inverted. The image is inverted. The image is smaller than the object. The image is smaller than the object. These are the characteristics of image formed when the object is beyond C, the center of curvature. Okay, let's move on and see when the object is at C. When the object is placed at the center of curvature C. Let's look at the diagram again. AB is the object. The ray of light from the head of the object, from A, striking the mirror at D, reflects back through F. The ray from A, the head of the object, and that ray is parallel to the pole, the principal axis. It's parallel to the principal axis. So, striking the mirror at D reflects back through F. Now, another ray that is parallel to the principal axis is at the base, that is from A prime. That ray is also parallel to the principal axis, striking the mirror at E, reflects back through F. Therefore, the meeting point is at A prime, and the image formed is B prime, A prime. While the object is AB, the image is B prime, A prime. From this, you can deduce the characteristics of image formed. Let's look at it at the right hand side. The image is formed at C, at the center of curvature. The image is formed at C. The image is real. The image is real. The third one, the image is inverted. The image is inverted. And the last one, the image is the same size as the object. The image is the same size as the object. All right, let's move on. Please, I want to believe you're following gradually. All right, let's look at the fourth position. When the object is between F and C, when the object is between the focus F and the center of curvature C, so the object is AB. The object is AB. Now, the ray of light that is parallel to the principal axis strikes the mirror at D. That ray strikes the mirror at D, and it reflects back through F. Ray parallel to the principal axis from A to D, striking the mirror, reflects back through F. Also, the ray parallel to the principal axis at the base from A prime, striking the mirror, also reflects back. And so, if that is the case, then the meeting point is at A prime. And so, the image formed is B prime, A prime. The object is AB, and then the meeting point is B prime, A prime. Please, I know that because this is more or less a virtual class, you can draw your own. Of course, from the homework I'm going to give to you, you will draw your own. Then based on the rules, all these rays are based on the rules. If you follow the rules, the 3 rules we gave before we started looking at the formation, all these diagrams and these rays, you can draw them. You can draw them. So please, I want you to systematically and analytically follow the diagrams and the explanation. All right. So, what are the characteristics of the image formed? Number 1, the image is beyond C. That is B prime, A prime. So, it's beyond the center of curvature. The image is real. The image is real. The image is real. The image is inverted. The image is inverted, is upside down. And then the image is larger than the object. If you look at it very keenly, you discover that the image is larger than the object, the B prime and A prime. All right, let's look at another position. When the object is at principal focus F, when the object is at principal focus F. The object is AB. The object is AB. So the ray of light from A to the mirror at D, the ray of light from the head of the object from A to point D will reflect back through F. So the ray coming from A to the mirror at D reflects back through F. Another ray is coming from the center of curvature. That ray is the line YCAE. YCAE. That ray that will pass through the center of curvature must definitely reflect back through the same path. It must reflect along the same path. And that path is still YCAE. So it will now be EACY. EACY. That's the third rule given while you're constructing the diagram for the images formed by curved mirrors. Okay, and so what are the characteristics of the image formed therefore? You discover that we couldn't get any image, but the image is going to be formed at infinity, at a very far distance. The rays will continue to prolong, continue to move until they have a meeting point, and it's going to be at a very far distance. So that is why it's at infinity. And of course, the higher the distance, the larger the image. And that is why the image is larger than the object. The object is AB, but the image formed is going to be larger than the object. So the image is larger than the object. Okay, let's look at the last position. When the object is between F and P. When the object is between F and P. The object is AB, between F and P. F for focus, P for the pole. When the object is between F and P. Following those rules, and then you have the rays meeting at A prime, but behind the mirror. The rays meeting at A prime behind the mirror. And any image formed behind the mirror is a virtual image. Any image formed behind the mirror is a virtual image. So the characteristics therefore are: number one, the image is behind the mirror. As you can see, is at the back of the mirror, and the image is virtual. Since it's behind, it's virtual. And then the image is upright. It's upright. You can also say it's erect. It's erect. And then the image is larger than the object. The image is larger than the object. From that diagram, you can see that the image is bigger. It's larger than the object. All right, let's look at the type of image formed by convex mirror. So images formed by convex mirror. Please take note of this. Whatever the position of the object in a convex mirror, virtual images which are always erect and smaller than the objects are formed. For every position on the convex mirror, the characteristics are the same. Virtual images, erect images, and the images are smaller than the objects. These are the characteristics of images formed by a convex mirror. So now look at the object from the diagram. Look at the object at the left-hand side. The left-hand side is where the reflection of light is taking place, and then the image is formed at the back of the convex mirror. This is a convex mirror. So at the back, that's why you're seeing those lines. They are represented with broken lines to show that they are virtual. They are virtual. They are not real lines, till they are virtual lines or virtual rays, and then they will definitely form virtual image. Virtual image. Please take note of this. All right, let's proceed. Let's look at the application of curved mirrors. The application of curved mirrors. The uses and the functions of curved mirrors. They are used in touches. They are used in touches. They are used as shaving mirrors. Curved mirrors, concave mirrors. Concave mirrors are used in touches. Concave mirrors are used as shaving mirrors. They are used as shaving mirrors. Concave mirrors are used in car headlamps. They are used in car headlamps and then in reflecting telescopes. Reflecting telescopes. So these are the uses of concave mirrors. Let's look at convex mirrors. They are used as driving mirrors because they give erect images and have wider field of views than plane mirrors of the same diameter. They are used as driving mirrors because they give erect images and have wider field of views than plane mirrors of the same diameter. Now, the side mirror of a car is made up of a convex mirror. That side mirror is made up of a convex mirror. And most of the time, they write objects are closer than they appear. Objects are closer than they appear. Most of the time, they write that on the mirror. All right, let's go further quickly. Mirror formulae. Mirror formulae. If the image distance is V, the object distance is U, and the focal length is F. If the image distance is V, the object distance is U, and the focal length is F, then the mirror formula is given by 1 over V plus 1 over U equals 1 over F. 1 over V plus 1 over U equals 1 over F. V is the image distance, U is the object distance, and F is the focal length. Now for magnification. Magnification is how big the image is to the object. So the linear magnification of a mirror is the number of times the image is bigger than the object. The linear magnification of a mirror is the number of times the image is bigger than the object. And the formula for finding the magnification, the formulae are image height over object height. That's one. Another one is image distance V over object distance U. So depending on the problem, depending on the question, you can use any of these formulae to solve the problem on mirror. All right, let's look at an example. Let's take just one example. An object is placed 30 centimeters from a concave mirror, focal length 15 centimeters. Find the magnification of the image produced. An object is placed 30 centimeters from a concave mirror, focal length 15 centimeters. Find the magnification of the image produced. Solution. Let's list out our parameters. We have the object distance, u, which is 30 centimeter from the question. The focal length, f, equals 15 centimeter, also from the question. But the image distance v was not given. We were not given the image distance v. So we are going to find the image distance first before we can now find the magnification. You can't find the magnification until you have v and u. And in the question, we were not given v. So let's find v. Step 1. Using 1 over v plus 1 over u equals 1 over f. 1 over v plus 1 over u equals 1 over f. So step 2. The v is the v were not given, but were given u. So 1 over 30 plus 1 over v equals 1 over 15. The v was not given, but we have u. So 1 over 30 plus 1 over v equals 1 over 15, where f is 15. Now, if you make 1 over v the subject, don't forget that whenever any algebraic term or any number is changing position from one side of the equality sign to the other, the sign changes. So 1 over 30 going to the other side, 1 over 30 from step 2 going to the other side in step 3 will become minus. So we now have 1 over v equals 1 over 15 minus 1 over 30. In step 3, 1 over v equals 1 over 15 minus 1 over 30. Step 4, 1 over v equals, find the LCM of 15 and 30. The LCM of 15 and 30 is 30. So how many times can 15 go in 30? 2 times. 2 times 1, 2. Minus 30 in 30, 1. 1 times 1, 1. So that is why we have the numerator at the right-hand side to be 2 minus 1. 2 minus 1 equals 1. So in step 5, 1 over v equals 1 over 30. 1 over v equals 1 over 30. Step 6, cross multiply. To be able to find v at this point of step 5, cross multiply. And if you do that, v equals 30 centimeter. Now, having found v to be equal to 30 centimeter, we know that magnification m equals v over u. Magnification m equals v over u. So step 7, m equals 30 over 30. M equals 30 over 30 because v is 30 and u is 30. So magnification m equals 1. Magnification m equals 1. All right. We have come to the end of the lesson, but there is you have assignment here. There are 2 of them. The first one says, draw the position and nature of image produced by an object placed at the following points on the concave mirror. Draw the position and the nature of the image produced by an object placed at the following points on the concave mirror. The first point is at the focal length. At the focal length. And then the second point or the second position is at the center of curvature. At the center of curvature. Follow those rules and you'll be able to draw them. The second question. A concave mirror of radius of curvature 20 centimeter has a pin placed at 15 centimeter from the pole. What will be the magnification of the image formed? A concave mirror of radius of curvature 20 cm has a pin placed at 15 cm from the pole. What will be the magnification of the image formed? What will be the magnification of the image formed? Please try these questions and then send them to my WhatsApp number or my email. The WhatsApp number is 08034796589 and the email is princeoluwaseun91@gmail.com. Wow, I hope you have enjoyed this lesson. Please do the homework and then send to me so that you can as well get a feedback. And I want to say that if you have any question at all, please feel free to send it through my WhatsApp number or my email. I will definitely attend to them and then give you the feedback. It's all right. Please take care of yourself and then stay safe. Bye.